look over on the left-hand side of the page real quick. I do want to touch base with 9, 10, 11 because those were briefly covered, but not like super duper. So I would write this part down. So your rate of dissolving. When we're talking about rate of dissolving, we mean how to dissolve faster. Okay, how to dissolve something faster. So the 3 ways to do that is you increase. Do you guys know what I mean when I put the arrow as being increase? Hopefully, if you don't, just ask me, okay? So increase temperature means crank up that temperature. What that does is it moves things quicker. Dissolving involves collisions. It involves those water molecules grabbing those ions and pulling them apart, right? So the more movement we got, the more collisions we'll have. So if we increase temperature, that'll take care of it. If we increase surface area, so we'll talk about that in a second. Okay, if I increase surface area, then I'm allowing more areas to be hit by those water molecules. So again, more collisions. And if I increase agitation, agitation is a fancy word to say stirring. Okay, just means stirring. So I don't like to say that this is common sense, but this one is common sense. All right, it's I think we've all either experienced trying to dissolve some sort of a salt or some sort of a drink mix in water. You know that if you just dump the powder in the water and sit there and stare at it, it's not gonna dissolve. It's just gonna go right down to the bottom, right? You have to stir it. You have to agitate it. You also, believe it or not, knew the surface area one. We probably didn't know the temperature. That one I'll give to you, okay? Unless you dealt with water trying to dissolve salt, okay? By the way, can we just cross out number 10? Because I feel like if I gave you all the ways to increase, do you know what the ways are to decrease? It's going to be opposite, right? Decrease, decrease, decrease.
What about the surface area now?
It'd be to decrease your surface area. Yeah. But let's talk about that real quick. So number 11 says, what does it mean to increase your surface area? All right. So if you've ever had that situation where you a little bit of the humidity got into your canister or powder drink, whatever, okay, and it all clumped together, can you just put that clump in the thing and expect for it to dissolve? No, you have to do what? Break it apart, stir it, whatever you got to do to make it crumble, right? So when we say to increase surface area, we mean that you need to break up, crumble, grind, whatever. I'm running out of words. All right, but we're basically taking some big chunk, okay? We're going to break it into littler pieces. Now, that kind of sounds wrong, right? But you just told us to increase surface area. Yes. Listen to this part. All right. This right here, I'm trying to show you a sugar cube. So most of us have rolled a dice at one point in our life. How many sides are there on a dice? 6. There are 6 sides to any cube, right? There are 6 sides. That means there are 6 sides for the water molecules to hit. Okay, so there's those collisions again. If I took that big sugar cube and I broke it into 6 little cubes. Here's my impressive not drawing skills, but I'm trying to be quick. That's pretty quick. Not bad, not bad. All right, how many sides did I now just create if I have 6 smaller cubes? How many? 36. I just made 36 sides. If you have no idea where that number came from, it came from having 6 cubes, each have 6 sides. That makes our 36 sides. So when we break something up into smaller pieces, you are allowing more area for that water molecule to go in there and hit it, and therefore dissolve it. So once there's that common sense part again, we know you don't leave a chunk really big. You got to crush it up in order to get it to dissolve. You just didn't know that it was increasing surface area. So that's the part that you want to study. That's the part that you want to memorize. Okay? All right. I still have 6 more minutes, so I'm going to keep going up the page as far as you guys want. This is number 11. Oh, it says, what effect is increasing surface area? Oh, increases solubility. All right. So with electrolytes. So electrolytes, just a reminder, when we had talked about electrolytes, I'm not going to be asking about strong and weak. So the way to recognize an electrolyte versus a non-electrolyte. So electrolytes were things that were ionic. So we're going to look for metals. We're going to look for acids, which means they start with H. We're going to look for bases. That means they end with OH. And we're going to look for anything like tap water, not distilled. All right, so all of those are electrolytes, all right, because they break into ions. All right, so an electrolyte is just going to be a substance that when dissolved conducts an electric current. So that's basic stuff. You guys already knew that part, okay, because it has ions. Don't worry about fully dissociating versus partially. I'm not going to ask you about that. A non-electrolyte will not conduct electricity. Did I misspell that? Not conduct. Okay, so don't worry about strong and weak. Again, we're just doing electrolyte or non-electrolyte, okay? So for distilled water, that will be our non. Tap water, definitely. Gatorade, definitely. Sugar solution, non. That's a covalent compound, okay? HC2H3O2, that's something that starts with an H. That means it's an acid. That is an electrolyte. It's acetic acid or vinegar. KOH, so we end with OH. That's an electrolyte because it's a base. HCl, electrolyte. NaCl solution, so that means that we have a metal in there. That's an electrolyte. And then soap will be your non. Okay, so you only had 3 nons: distilled water, sugar, and soap. We're down to the last 3 minutes. Do you want me to keep going up the page? Some people say, okay. All right, we'll keep going. All right. So with mixtures, so compare the properties of each type of solution. So when we're talking about size of particles, solution will have small, colloid will have medium, suspension will have large. Do the particles eventually settle? As in, do they sink to the bottom? No, no, yes. Homogeneous or heterogeneous? We're going to say homogeneous for solution. Colloid should have been blacked out. That's because it appears homogeneous, but it is heterogeneous. I'm not going to ask you about that. And then suspension will be your example of a heterogeneous. It's chunky, okay? Shows the Tyndall effect. Does everybody remember what Tyndall effect was? That was when I took the laser beam and you got to see the red light go through or you didn't see it go through, right? So this should be a no, yes, no. And then an example of each of these would be salt water, milk, and muddy water. Okay, the Tyndall effect will be scattering light particles. I don't know why I wrote it like that, sorry. And the only one that exhibits it is going to be a colloid or milk. Okay. In a sugar water solution, who is your solute? Sugar. Solvent is going to be the water. And the first two questions, number 1 should be D. Number 2 should also be D. Make sure you read those. Don't just take that answer. All right. Okay, you have to